This video is designed to help walk you through your activity that you need to complete at home. So while watching the video, you should have your handout right out to the side, and so you can follow the same steps and also do the same things that I'm doing on your computer as you're watching the video. So the first thing you're going to do is open up whatever internet browser you use, although I would recommend not using Google Chrome because it has had some issues with GeoGebra, but Internet Explorer or Firefox or Safari should work just fine. And then you're going to type in www.geogebra.org into the internet browser, and that'll bring you to the GeoGebra homepage, which will prompt you to download. So go ahead and click download, and don't worry, it won't actually download anything onto your computer. What you can do is unless you want to download, if you want to download, it's fine. It's free and it's a really cool app. But if you don't, if you're afraid of downloading anything onto your computer, you can just click on Applet Start, and it will allow it to run as an internet applet with internet access and not actually download anything onto your computer. It's a nice feature of GeoGebra. Alright, so once you've got this window, let's go ahead and begin walking through your steps. So for you, problem 1, it says to type in y equals x squared minus 3 into your input bar browser, and then hit enter. When you hit enter, the graph will appear, and then it will also show the equation right there. And let's go ahead and change our view for a second. So go over to options and go down to settings. And let's go to graphics. Let's have our x-axis go from, well, I think -4 to 6 is fine, or -4 to 7. Actually, no, let's make it -5 to 10. And let's have our y-axis go from, how about -8, I guess, -5 to 5, I guess. And we'll have the x-axis go by ones, and let's have the y-axis go by ones as well. It'll just make things easier. Okay, so there's our view of our function. Now, what we want to do is find the derivative of this function, so we're going to first begin by defining a point to be on this curve. So in your input bar, type in point, and then we're going to have a point that's on this graph, y equals x squared minus 3, and if you notice, GeoGebra has named it C, so we'll just type C in there. And if I want to move C around, I can just click on this arrow icon in the top left, click on the point, and you can move it around, and you can see that it's stuck on the curve, which is exactly what we want. Now what we want to do is get a line tangent to the curve at that point. So if you go to the fourth icon from the left, this one here, go down to tangents, what you need to do is click on the point and then click on the curve, and that should create a line tangent to the curve at that point. I'm going to click on that arrow again so I can move it around, and we can see that the line in fact is tangent to the curve at that point A. And what we're going to do is find the derivative for this the same way that we found the derivative for sine in the notes. Is we're going to create a point that has the same x coordinate as point A, but where the y coordinate is the slope of the line tangent to A, because that will allow us to get a collection of all the different tangent lines at all the different points. So I start by just saying x is going to be from this point A, and I'm using capital A because that's the name that GeoGebra gave my point. Your name might be different, so you should type in whatever letter you were given. And then for the y point, we're going to type in the slope of this line lowercase a, because that's the name that GeoGebra gave my line. It might give your line a different name, so then type in whatever it gave your name there. So then I have this point B. So now what I want to do is see what the different points for B are as I move point A along the graph. So I'm going to turn the trace on for B, and I'm going to move my point A along the graph, and I'm going to kind of try to solidify it here. Okay. So what I notice, and what I want you to do in on your worksheet, and you're supposed to write this down in your worksheet, is make a conjecture. what equation do you think fits this new graph that I have, this new tracing graph? Well, first of all, I can tell it's linear. It's a straight line. So I need to figure out what the slope of this line is and what the y-intercept is. I can clearly see the y-intercept is 0. And if I look at the slope of the line, I can tell that it's going up 2 for every 1 that it goes over. Up 2 over 1. Up 2 over 1. So it looks like the slope of this line is 2. So to verify, I'm going to see if I'm right. I'm going to type in y equals 2x just to see if I had the right graph. And you can kind of see it. Let's go ahead and change the color of this so we can see if it comes through. Let's make it a bright red. And let's make it thick so we can see it. And there it is. So it was in fact the same thing that I just traced in. So then you make that conjecture. Now on your worksheet you have to use the formal definition on this function x squared minus 3, and your answer should end up being 2x. Also, what you're going to have to do is print out this image. You're going to have to print out this image as well as the images for problems 2, 3, and 4. And those are all going to be due on Monday. So to do that, you could just hit File, and I believe you could print from here. If not, you can save it as something and then print it as a file. And then if you want to save it as a picture, you can go to Export. And you can save it as a picture. It would give you this menu. You'd hit Save. And then I can choose where I want to save it. I'll go ahead and save it to my desktop right now, and I'll just call it problem number 1. And then that will appear on my desktop. And then I can open it and print it from there. So you'll have to print each of the 4, and you'll also have to work out on the worksheet. You'll have to use the formal definition on this equation to get your answer for each one of the 4. And it's basically just like a second part of example 1 from our notes. And if that still is a little fuzzy to you, then you can come in and see me and I can help you work through those. So best of luck to you, and I'll see you Monday.